Why is Euler's number so important? Well, we'll start off with regular exponents. Start off with the basics. X squared is equal to x times x. X cubed is equal to x times x times x. X to the power 4 is equal to x times x times x times x. You get the idea. What if we switch the bases in the exponents? We switch these. Well, this would just become 2 to the power x. Now, some of you might be able to recognize that this is just an exponential equation. If we plug in 1, 2 to the power 1, we get 2. If we plug in 2 to the power 2, we get 4. If we plug in 2 to the power 5, we get 32. Plug in 2 to the power 8, we get 256. That looks pretty exponential, because for every value of x, it doubles from the previous term. So we can conclude that the derivative of 2 to the power x is itself. d 2 to the power x over dx is just equal to 2 to the power x, right? Well, not quite. Let's simplify this. This just becomes 2 to the power x plus dx minus 2 to the power x all over dx. And we can just use distributive property, and we can factor out the 2x, because that's how exponents work. We get 2 to the power x times 2 to the power dx minus 1 over dx. Now, as we do with derivatives, we like to plug in very, very, very small values. So let's start off with, let's say, dx is equal to 0.0001. Well, this equation just becomes 2 to the power x times 2 to the power 0.0001 minus 1 all over 0.0001. And if you plug this into a calculator, this right side of the expression is somewhere around 0.6931. Alright, let's plug in a smaller value. 2 to the power x times 2 to the power 0.000001 minus 1 over 0.000001. Well, this is also somewhere around 0.6931. Alright, so it's clear we have some sort of constant. So, is there a number where the derivative is just equal to the number? Derivative of some number to the power x is just equal to that same number to the power x? Short answer is yes. It's e. That's why it's so important, because this pops up everywhere. Say instead of 2, we have e. This is just ex times e to the power 0.000001 minus 1 over 0.000001. Well, this right side of the expression, this is somewhere near 1. It approaches 1. The smaller dx is, the closer this gets to 1. Well, why e? That's what e was made for. That's the whole purpose. If we plug in e, then we can just get d of e to the power x over dx, and this is just equal to e to the power x. This constant over here is just 1. And that's why it's so interesting.